Bismillahirrahmanirrahim. Today we will learn about algebraic manipulations, which contains actually two major topics, HCF and LCM of algebraic expressions. If we read the definition of HCF, it states that if two or more algebraic expressions are given, then their common factors of highest power is called the HCF of the expression. When normally the question or the numerical is written or it is given, we first factorize the algebraic expression if we have to find the HCF by the process of factorization. Similarly, for LCM, we have to take out something common, or we need to factorize. Actually, either we want to find HCF or we want to find LCM. In both ways, we have to find LCMs and HCFs. For that purpose, we have to factorize actually, which is a requirement of both these type of questions. Either this is HCF or this is LCM. Now, if I explain you, actually HCF is calculated by two methods. One is, I just told you earlier, that by factorization, and the second one is about by division. So for the explanation of HCF by factorization, I would like to give you the explanation for HCF in this way, that if we are provided with two terms or three terms which are algebraic expressions, and we want to find their HCF, the process will be that we will first find their factors. Now, this is actually the application of the process of factorization that you must have learned in your previous topics. For finding HCF, a person or a student must be expert enough to factorize the given expression, because the factorization are the earlier topics, and in this topic or in this chapter we are studying about the application of factorization. So a student should be efficient enough to factorize the given algebraic expressions. So by the time in all of these questions which are written under this topic or in this chapter, you will notice that factorization is done for many parts, for many questions, but the factorization will not be uh, quite difficult sort of factorization. It will be the simple factorization. As you can see that in this example, x square minus 4 is actually written as x plus 2x minus 2, and I have given a reference in the box that you can see that this is the factorization of the form a square minus b square. So 4 is actually written as what can I can explain you. 4 is written as like this is 2 square, 2, and then if I place it square, it's written as 2 square, so that it will become equals to 4. So this is a breaking up of or break apart of this number 4. This is 4. It is written as actually 2 square, and then 2 is taken as b, you can see, and then we have applied this formula, difference of scale formula, one time negative, one time positive. So this simple expression is converted into x plus 2 and x minus 2. Then this next term, that is x square plus 4x plus 4, this whole term, this is actually what you can see. It is because of the factorization of an expression which is called whole square formation. Means that if we have a plus b, and we need to just show a complete square, Then the factorization is of the form like a squared uh, whole square equals to a squares plus b squares written as a square plus b its square plus 2 times ab, and the factorization is of the form for this part only. You can see that this whole part is actually equals to this number. I spaced it, make it like some certain distance. It is the factorization of this sort of number for this part only, because first term x is written as x whole square, whole is written as whole square of 2, and 4x is actually broken up like this one. Actually this is 4x. I just give you some explanation. This 4x is 4x is actually equals to 2 times 2x times 2 x. This is just the explanation of this 4, which is broken up actually 2 times AB. This is 2 times AB. Just giving you the explanation that how we have done it. If you want to further simplify it, actually as x whole square as a whole square, I place a bracket around it like this way, x squares, and then 4 is written as 2 its square, and then this is 4x, which is actually equals to, what should I say, if I just remove it, like, then this whole part will become equals to x plus 2 and its whole square. So this is actually how we have formed it with this reference. So in fact, what I want to tell you that actually this is a application of factorization, that how to factorize. Basically, this is not the topic of factorization, but we should know about the factorization. So once you have done the factorization of first part, second part, and for third part, and this is we have done by using midterm breaking. So because of the midterm breaking, we have solved it into two factors, x plus 2 and 2x minus 3. So by using the midterm breaking, and if you want to revise it, that how did we perform the midterm breaking, for that purpose you must remember that we have uh, to multiply two parts, like these two are multiplied together, 2 and 6. So this becomes actually 12, and then minus 12, and then we make the factors of minus 12 such that midterm plus 1 is actually converted into 4 minus 3x. So midterm is broken up, this 1x is broken up actually 4 into minus 3. When you will multiply 4 and minus 3, it will become equal to the product of -6 and 2, that is -12. The two purposes should be fulfilled, that sum of the middle term should be, these two terms should be the equal to middle term, that's why this is called the midterm breaking. And the product of these two terms should be equal to the product of extremes, that is -2 and 2. So this gives you the two factors by taking common from first two parts. If just give you the short explanation. I have taken common from this part, and I have taken common from this part. These two parts. From first two parts I have taken 2x common, and from next two parts I have taken -3 common. You can see that. So once it has been done, then x plus 2 is taken as common. If I further explain, these two parts are taken as common, and in this way you have gotten x plus 2 and 2x minus 3 as two factors. So in this question, actually, I have explained three things. One, three types of factorization. One is by midterm breaking, that is in the very first step. You can see that these two terms are broken up or shown as the factors of two terms, x plus 2 and x minus 2. Second term is actually the form of factorization, which is a plus b whole square form. So it is converted into this expression as of square of two terms, sum of two terms, and they are then further split into two multiples, x plus 2 and x plus 2. In the third part, we have used a midterm breaking pattern because every part is different. So in this way, we have done the midterm breaking for the factorization. And for factorization, I have explained you, we will get these two factors. Now we have to see that three terms which were given in the question, we have to see which two factors were actually common. So x plus 2 was a factor in the first term, x plus 2 is a factor of, in the second term, x plus 2 is also a factor of third term. So that's why x plus 2 will become the HCF of all these three given terms. So HCF or highest common factor will be x plus 2. So this is the first part, that how do we solve HCF by factorization. Now I would like to give you some other examples as parts of the exercise. So in this first part, in which we have to find HCF of the expression, if you have very simple expressions like 39x raised to power 7, y raised to power 3, z, and 91x raised to power 5, y raised to power 6, and z raised to power 7. These type of parts can be a part of MCQs or short questions. What you have to do, that because these are very simple parts, the factorization will be done by splitting these two. Like 39 will be broken up as multiples of prime number, 13 into 3 and x raised to power 7. So this will be written as 7 times. Y raised to power 3 will be written as 3 times, and z will be written as 1 time. 91, second term, it will be factorized as 13 into 7, that is prime factors. 13 into 7, x raised to power 5 will be broken up into 5 multiples of x, and y raised to power 6 will be written as 6 times y, and z raised to power 7 will be written as 7 times z. So this will give you the factorization of these two parts. So in the very first, you have to find just a moment. We have to find that what is the common. So you will notice that in these two terms, So you will see that what is common for this part. As well as numbers are concerned, you will see that 13 will be taken as common in both of these numbers. 13 will be taken as common, and then you have to see that what is the least power of x. This is x is to power 5, this is x is to power 7. So these 5x will be taken as common, least power will be taken as common. Similarly, y6 and y3, you have to take up y3 as least power of uh, least uh, power of y. So it should be 3. So if we simply place the variable y here, so you will see that at the end, the answer will be 13x raised power 5, y raised power 3, and z raised power 1 and z raised power 7. Both of these z contains z raised power 1 as a least power. So from both of these numbers, we have taken out the common parts, that is 13, x raised power 5, y raised power 3, and z. Similarly, for second example, 102, 85, and uh, 187, these three numbers, which are actually the numerical 102, 85, and 187, those are broken up as multiples of prime numbers. So prime numbers, what are the prime numbers? That do have only two divisors. Numbers which have only two divided one and itself, those are called the prime numbers. So we have to break up these numbers 102 or 85 and 187 into prime numbers only. You will break up 102 as 2 into 3 into 17, x, y, z, and y raised power 2 will be written as. Similarly, these two other numbers will also be converted as multiples of prime numbers, and then you will see what is common. So if we notice about it that uh, these numbers, what are common right here, so that is, if I just placed it right here, you will see the 17 and the number 17, and obviously another number, it is also 17, which is common for all these three parts right here. So from the numbers you will see that 17 is taken as a common factor, and then as told you earlier that from these three numbers you have to see which is the least power. So x raised power 1 will be taken as least power, y raised to power 1 will be taken as least power, and z raised to power 1 again will be taken as least power. So this will give you the HCF. 17x by z will be the HCF of these three terms. Now, okay, for maybe I have taken another example to explain you further that if you are provided these three terms and you have to factorize the given terms, how will you proceed for that one? If you take up the first part, x3 minus 27, so you have to consider what is the formula for factorization of these type of expressions. This is a very simple example. You can see that this is the formula of a raised to power 3 and minus b raised to power 3. This is called the difference of u formula. So this returns equals to difference of a and b, and then the remaining terms are like this one, that is a square plus ab, and then finally b squares. This is the requirement of the formula. So by using this formula, this term has been expanded into these two factors, like you can see that. And for this part, because every part is different for the factorization, so this part, midterm breaking has been done for the process. This is the midterm breaking for the process of factorization. As told you earlier that how to we do the midterm breaking. This is by using difference of scale formula, factors by difference of formula. So 1, 2, 3 equation actually gives us the factors of these three given expressions and what is common, whatever is common between these three numbers, which will be taken as the highest common factor. H.C.F. For this question, it is x minus 3. Okay, for finding LCM, uh, we have to go through the procedure of finding HCF as told you earlier. For finding LCM by factorization, we have to factorize the question or the terms of the question as usual we have done for HCF. And we have to find the common factors as well as we have calculated and finding HCF by factorization process. So you can see that if you want to find LCM by factorization, for that purpose, we will have to find HCF by factorization first. So the same procedure will be followed as I told you earlier that like this 39 will be converted or converted into multiples of prime numbers and 91 will be again converted into multiples of prime numbers. And x to the power 7 is written as separately x 7 times, y 3 times, and z 1 time. Same is done for the second part. I have written it separately. All these parts are written separately. Then the first task is that we have to take out common. So for that one, we will see that what is common. So the common part which are written here, I would say 13 should be here. This is written as 12. In fact, this is 13. Uh, so 13 and then see that the common part in both of these numbers is 13. X is to power 5 because least power is taken as common. Similarly, y3 and y6, we will take out y3 as common and 0 is per 1 and 0 is per 7. We will take z as common factors. Then for non-common factors, whatever is left now, after taking common, what is left uh, among the terms of factors, we have to separate those because for finding LCM, we also have to find what is not common between the factors of two terms or three terms. Like in this case, if you just see that what is not common among the terms, then we will see what is not common. So this is for the explanation. If I just give you the way like 3 and this number 3 is also is not common with any other number. So this will be written as non-common factor 3. Similarly 7, this is not common. You can see that it will also be written as non-common factors. Then you can see that we have taken x is per 5, x is per 5. These were actually the common parts. So only x is 2x will be this part. If I just highlight it, that these two x's, these two x these are actually such two parts of x which are not common. Similarly, three y's will also be taken as which will not be common. So the point is that like for this part, three y's, this will also be taken as not common part because three were common and the rest of three will not be common. Similarly, z raised to power 1 was common and z raised to power 6, if you leave 1 and we write or underline 6 z's, then these 6 will are written separately in this part. These are actually non-common factors. So all the numbers which are not common between these two factors, those are separately been written. And what is common or common factors, those are all already separately been written. Now to find LCM, you have to write the product of common factors and product of uncommon factors. So you will get them multiplied. So 13, 3 and 13 into 7, 13 into 3 into 7. These three numbers will be written as the product or the multiplication, and the remaining numbers you will write step by step. The common factors first and then the uncommon factors, and you will finally multiply them together to get the answer. Now, just to explain you one thing that uh, directly you can see that whatever is the highest power of x, like this is x raised to power 7, this is x raised to power 5, you have to take up or you will take up highest power in case of LCM, x raised to power 7 and for y raised to power 6, you will see that this is the highest power, so you will see that answer will be y raised to power 6, and z raised to power 7 and z raised to power 1, what is highest power, it will be taken as or answer will be with the highest power. So z raised to power 7 will be actually, this will be taken as the answer of LCM. So I hope that you will be able to understand. I have explained you in this video that how to find LCM and HCF by factorization. If we take another example for finding LCM by factorization, and the expression of the terms are in the compounded form like x is power 4, y is power 4. So once we will factorize these two parts, like by applying difference of scale formula, x is power 4 and y is power 4 will be written as x squared whole square, y squared whole square, and applying difference of scale means one time negative, one time positive. These two numbers will be factorized in this way. And then if you further factorize it, like this part is further factorized, once again it will give you x plus y and x minus y. So this is the labeled as first part, or the factors or the complete factorization of 2x raised to power 4 minus y raised to power 4. This is in equation number 1. For second part, 3 is taken as usual common, and then first two parts it has been factorized by taking x square common from these two parts, and y raised to power 2 common is taken from last two parts. So these two terms will be factorized like this one. So once the factorization is completed, you can see that from 1 and 2, we will have to find LCM by first finding what is common. So you will see that x plus y and x minus y, those are the common factors. So the common factors will be written once. As you can see that what is common, x plus y and x minus y are written as common factors. Then you will see what is left. Which factors are left, like 2 and 3, they are not common, so those will be written as multiple of uncommon factors, 2 times 3. And the x plus 2 and x square plus y square, because both of these are also uncommon between these two factors of these two terms, so you will get them multiplied as well. So this will give you these whole of this expression 2 into 3 x plus y, x minus y, x square plus y square, and x plus 2y as LCM. You can leave the question in either form. 2 into 3 can be written as 6, x plus y, x minus y. They will be get together or multiplied again to generate x raised to power 4 minus y raised to power 4. Either you can do it or you can leave the question even in this format. So in this way you will find the LCM of expression. So I hope that you will understand now that in this video we have discussed about HCF and LCM by process of factorization. In the next video, we will learn how to find LCM and HCF by the process of division.